All right. Hello, everybody. I'm excited to get started. My name is Matt Brems. I use he, him pronouns, and we're going to kick off here in probably about 2 or 3 minutes. We're going to let people take another minute or so to join us. So if you need to run and grab a drink or stretch your legs or something like that, we'll kick off here in about 2 or 3 minutes. As you'll notice, the webinar is being recorded, and we'll be able to make a recording available to everyone afterward. So we'll get started, like I said, in about 2 or 3 minutes. All right. Hello, everyone. We're going to get started here in about 30 seconds. We will be sharing the recording with folks once we are finished. We'll give folks another minute or so to hop on, and then we will get started. All right, so it looks like we are ready to go ahead and get started. Thank you all so much for joining today. Very excited to welcome you all to our event today. Specifically, the webinar that we're doing is how to build a Detectron model with Roboflow and with Paperspace Gradient. Before getting too far into this, want to reiterate or repeat that we are recording this, yes. And yes, we will also be making this recording available to you later. So you will all be able to have access to that recording. If you happen to be watching this recording, this is a great time to go ahead and pause and make sure that you make your Roboflow and Paperspace accounts so you're ready to go. Throughout the time that we've got together today, we want to be able to hear from you. So we very much welcome questions from you. On your Zoom screen, what you're going to be able to do, either at the top or at the bottom, depending on if your Zoom screen is maximized or what version of Zoom you've got, there should be a little box that says Q&A. And so if you click that box, you're going to be able to submit questions to us, and then we're going to be able to take a look. So please feel free to share questions with us at any point in time. We're going to have questions and answers available later at the very end of our time together today. So today, just giving you a little bit of a run of show and introducing our presenters and all of that. We're going to walk through a few things with you. We've got two amazing presenters that I'm really excited to introduce. We've got Jacob Solawetz, ML engineer with Roboflow, and we've got Rachel Rapp, ML engineer and developer advocate with Paperspace. I'm really excited to have these experts in to show you a lot of cool things today. By the end of the webinar, there's going to be 3 things that you're going to be able to take away. First, you're going to know how to access and use public image datasets with Roboflow. Second, you're going to be able to pre-process and augment images and understand why you might want to do that within Roboflow as well. And then third, you'll understand how to build a Detectron2 model with Paperspace Gradient's free cloud GPUs. So the way that this is going to work today, first, I'm going to let our outstanding speakers, Jacob and Rachel, introduce themselves in a moment. Once we do that, Jacob is going to show you how to head to Roboflow to grab a public image data set, pre-process and augment those images, and get them ready to export. He's going to turn it over to Rachel. Rachel's going to step in, show you around the Gradient GPU console, and walk through a pre-written notebook to build a Detectron2 model using a GPU-backed notebook on Paperspace Gradient. And then once Rachel wraps up, we're going to have that time for questions and answers. However, if you've got questions during the time, when you have questions around what Jacob says or what Rachel says, feel free to ask them. And if we've got time, we'll address it right then and there. Again, there should be a button in Zoom called Q&A for any questions that you have, and feel free to just put those in there. My recommendation for you today is to sit back and just follow along with us. Like I said earlier, we are recording this and we'll make this recording available to you later. You're going to have all of the tools that you need to tackle and replicate each of these steps, and then repeat it with your own data set as well, including the recording that we've got and Roboflow and Paperspace. So final reminders or final recap for you. Ask your questions in the Q&A box throughout our time together today. Yes, this is being recorded, and yes, we will be sharing that recording with you later. So thank you all so much for coming. And now what I'd like to do is I'd like to introduce Jacob Solawetz, machine learning engineer from Roboflow. So Jacob, if you want to go ahead and take it away.
Awesome. Thanks for being here, everybody. Really excited to be able to walk through this webinar with you and work on training Detectron2 today. So I'm Jacob. I'm a machine learning engineer at Roboflow. I've been working in the AI ML space for a few years now, and really exciting to kind of be here at this point in time where technologies are developing so fast, and we have platforms like Roboflow and Paperspace where you can get started and kind of get off to the races using ML applications in a very short period of time. I remember kind of in my early days getting started with AI research, I would spend hours and hours configuring GPUs and wrangling data sets, but now luckily things are getting a lot easier. So just to kick it off here, I'm going to go ahead and share a little bit about what the Roboflow platform does, and then I'll pass it off to Rachel to do a little bit of a high-level overview of Paperspace before we dive into our demo today. But if you go to roboflow.com here, you can see sort of a bit of on our webpage about what we've been working on. We're basically working on a product that makes it really easy to start building custom computer vision applications. And we have a suite of tools that allows you to upload images, annotate your images, organize your training data, train a model, and then deploy. So today we'll be using Roboflow for these first few steps here to upload images, annotate them, kind of gather our data set, put that together into an organized data set, and then we'll be exporting it over to Paperspace over on this part of the training and deploy step. And that's a really seamless integration, and we'll see how all those things work together. So some examples of things that you can do with Roboflow. We have some examples up here of things ranging from aerial imagery to detecting things for card games or pistols, anything in the real world objects. You can think you can use Roboflow to train models to be kind of automatically identifying these things with computer vision. And some of this I think will become a little bit more clear as we go through the example today, and we really hone in on a use case, which we're going to be identifying cells from microscopic images. So that's a little bit about Roboflow. We're working on making this computer vision loop really seamless to be uploading, annotating, organizing, training, and then deploying models, and kind of going back through that process in an active learning loop. So now I'll pass it off to Rachel, and you can jump in and talk a little bit about Paperspace and what we'll be doing there.
Thanks, Jacob. Yeah, so as Matt said, I'm Rachel. I am an ML engineer and developer advocate here at Paperspace. I am calling in from Berlin, although Paperspace is headquartered in New York City. And I definitely second Jacob's sentiment about being happy and relieved to have these kinds of tools available. A few years ago, I actually worked on a Detectron2 project, and I found it really confusing to get the data in the right type of format. And I mean, Detectron expects things to be really a certain way. And it's just so relieving to have things like Roboflow and Paperspace Gradient to really make things a lot more straightforward. So on that note, I'm going to share my screen and show you guys a bit about Paperspace Gradient. And you can always go to gradient.paperspace.com for more information. So a huge blocker in adopting AI nowadays is not so much a model or algorithm issue as it is an infrastructure and tooling issue. Teams and individuals can waste tons of time just getting hardware, software, and tooling and everything to work. And that's really where Gradient comes into the picture. So Gradient is a suite of web-based tools. It also includes a CLI and SDK that really enable machine learning and data science teams and individuals to work with machine learning models in a lot of different ways. So we have GPU and CPU backed Jupyter notebooks. There's also experiments you can run and visualize model training, a model repository where you can store and deploy models in one click, and just all kinds of different tools that really facilitate working with machine learning models. And I'm going to go into that in a bit more detail later when we have the console open before diving into our Detectron2 notebook. So on that note, let's toss it back to Matt, and you can kick it off with the data.
Yeah, absolutely. Thank you. So really quickly, in case you missed it at the beginning, we are recording this. We're going to make the recording available to everybody. In a moment, I'm going to toss it over to Jacob to open things up with our BCCD data set. So Jacob's going to walk through how to get data via Roboflow and how to prep it and augment it and do all of the things, getting it ready for export. And then we'll toss it over to Rachel to be training the model using Paperspace Gradient. With that said, please feel free to ask questions, but beyond that, I'll toss it back to you, Jacob, so that you can walk us through things.
Yeah, sounds good. Yeah, just wanted to second what Matt said there on the questions too. Feel free to post those, and I know we're going to do Q&A at the end too. But I'll go ahead and dive right in here, and let's get our hands dirty. So the best thing about the data set we're working with today is that it's public. So if you go to public.roboflow.com, you can see a bunch of different computer vision data sets that you can work with, and you can just kind of pull them right down from there and get started. So today we're going to be using this BCCD data set. So like I said, it's public. The nice thing here is there's the versions of the data set, and you can just go to the version and then hit download. So this will be the link that Rachel will be training from and bringing in over into Gradient here once we finish our work on preparing our data set. But the question you might be asking is, well, what if I want to try to detect something that isn't on public.roboflow.com, which is kind of the ultimate question. And so today we're going to be walking through a little bit of an example of how you can actually get your data set together in Roboflow and kind of use our tools to automatically kind of put your data set together and then generate versions that you can train from. So if you go to roboflow.com and you sign in, you'll see that you arrive in your dataset dashboard here. And so this is kind of like where you're versioning projects and you're working on different organization of data sets. So we'll go ahead and create a new data set here. And we'll just call this dataset cells and annotation group cells. So today we're going to be using an object detection model in the Detectron2 suite. And Rachel will get a little bit more into the various models that are available and more into what Detectron2 is itself. But I know here that we're headed towards object detection, so I know I can select that data set type. So then we create data set, and then we're here in the upload page, and we'll want to be uploading our images to Roboflow so we can use it to pre-process, and then augment our images to prepare for training. So we go ahead and hit select files here, and have this data set here. You can see there's the blood images in it. So we'll go ahead and just load in this data set. And you can just drag and drop your data in. And it will upload to our Roboflow servers here. So we'll have it available for manipulation. So one thing you'll notice here is this data set that I'm bringing in from the public site is already annotated. So it's been already annotated to where you can see that the white blood cells have been identified as a separate kind of cell, along with the red blood cells. And these images have already been gathered from microscopic imagery, but you might not have annotated images, and that is okay. That's another thing that Roboflow is built for that I won't be demoing too much today, but you can go through here and you can edit your annotations and add new classes and everything, so you can be both uploading and annotating your data set all in one go. So now I'll go ahead and hit finish upload here, and we'll start loading it in. So one thing you notice there is that as we started to finish the upload, it asked us to split our data into train, validation, and test splits. So that is a useful concept to know, in that we're going to have a training set, which we're going to be showing our model to learn from. And then we're going to have a validation set where we're going to be printing out metrics as we're training to kind of see how well our training routine is working. And then we'll have a test set, which is what you can think of as kind of like the final boss that we're going to be finally testing to see if our model is doing well on. So so now we've got our data set loaded in here. Like I said, you can edit your annotations in here, and you can go through and kind of visualize and make sure that everything's going all right. And then another important thing that you can do in Roboflow is start to generate data set versions. So your data set is kind of like your ultimate source of where you have all your images and your data. And then as you go through and you train models, you're going to want to try different experiments. So it's good to be able to version your data and try different experiments on your data. And your versions in Roboflow will always be locked in place. And these are kind of a source of record for you to kind of keep all your experiments steady and in one place. So in order to generate a version here, we can go ahead and select some pre-processing options. So we have the ability to resize our images. So we'll go ahead and resize down here to 416 by 416. You can see other options that you have here for pre-processing. So pre-processing is going to apply to all of your dataset splits, so both train, validation, and test. And it's sort of like a way to standardize your data set. You can think about it. And then another thing you can do is use augmentation. So image augmentations are a way to actually manipulate the training set to slightly add little twists to your data set. So it's almost like you can gather a larger data set out of just a few base images. So for example, for cells, we might want to add some random crop in to simulate zoom, because our microscope images might be like at different levels of zoom of our microscope. And another thing we might want to do is we might want to add rotation in, because like the white blood cells and the red blood cells might manifest themselves in any kind of rotation we don't know. It's probably worthwhile to add these kind of augmentations. So as you're adding these pre-processing and augmentation steps, you want to really be thinking about the real world use case of where you're headed with this model. And when you deploy it into production, can you think of all the different ways that the camera angle is going to be, and the different shadings of light, and you really want to make it so you're constraining that domain and showing the model everything that might be in the domain that you're trying to get to. Those are at least some things that we've seen at Roboflow for making the best models that will actually perform well in the wild. And then to create a version, we'll go ahead and just generate a version. So this is where we'll generate images. And this is kicking off some servers at Roboflow to kind of go through all those images and make all those transformations and then package that up into a unique dataset version. Yeah, and then the best thing is here, so you can load your images in you can load them in essentially any format. You already have them. So if you're already working on computer vision projects and you have things in Cocoa JSON, but you want to go to YOLO v5 PyTorch, or you want to go to whatever model you want, like Rachel was saying, like all these models have really complicated data set formats. So one nice thing about Roboflow is you can just know that you've got your data in the right format and you can pick it up and go. And then if things aren't working, then you know it's a model question, not a data question. So this is the point where I'm going to pass it off. So here we have, you can pick your export in the right format. So I believe Detectron2 is Cocoa JSON. I don't remember, but anyway, so you go here and then you can get a zip of your computer, zip of your data down to your computer, or you can get a download curl link to go into a notebook, which is what Rachel will have today, is a curl link. So so with that, we got our data set ready, and we're ready to go off to the races here. So awesome.
Thanks, Jacob. So let me just share my screen. All right. So I'm going to pull up our Gradient or Paperspace console here. If you want to look at the console yourself, you can just sign up, make a free account. You can sign in or sign up with GitHub or your Google account or sign in. That's going to take you then to the console. These are our notebooks. I'm going to give you guys a little tour though before we dive in with our Detectron2 notebook. So we also have projects. These are workspaces for you and your team to work on different ML pipelines. And if we dive into a project, you can see that we also have experiments that you can run training. You can do different jobs, store your models after they've been trained, and deploy them in one click, as well as run tensor boards and lots of other different things as well. But today we're going to be mainly focusing on the notebook side of things. So I have our Detectron2 notebook running already. If you wanted to make your own notebook, either for another project or to do Detectron from scratch or whatever you wanted to do, you would just hit create notebook, give it a name, select an instance to run it on. So these are actually containers where everything is going to be pre-installed for you, so you don't have to deal with any messy tooling or configuration issues. But if you want, you can also come down to advanced options and use your own custom container as well. And after that, we're just going to select a machine to run it on. You have many different CPUs and GPUs to choose from, how long you want your instance to run before it shuts down automatically, and then set it to public or private. And if it's set to public, you can generate a link and share it with your team members or colleagues or anyone you just want to share your notebook with. One of the great things about Gradient is it makes it super easy to work with teams. You can see I've got my team here as well. So without further ado, let's dive into our notebook. So this is our...
Hey, Rachel, if I can jump in really quickly. Yeah. As you get started with this, a question that came in, what container did you choose in order to be able to run this?
Yeah, good question. So, and that's actually something I would have talked about right now as well. Detectron2 is a ground up rewrite of the original Detectron that runs on PyTorch. So I chose our PyTorch container to run this on. But we also have TensorFlow and several other containers with lots of useful libraries already installed. So this is our web IDE, super comfortable to use in the browser. You can see here we have our files listed. I can also change the instance that it's running on by just stopping the instance and choosing a different GPU. And if you click here, you actually get the full Jupyter experience. So without further ado, let's dive into our notebook. I hope everyone can see well. If not, just drop in the chat and I can zoom in a little bit more. So I'm assuming that most of you are already familiar with Detectron. If not, it's a library by Facebook. It enables you to do all different kinds of computer vision tasks. So here we're going to be focusing on custom object detection, object recognition, but you can also do things like semantic segmentation, key point detection, mask, dense pose, and so on.
Hey, Rachel, would you mind zooming in a little bit?
A little bit. Yeah. Let me just, sorry, I saw, yeah, the chat light up, but it didn't open. Okay. Is that good? I think.
Could you do one more, please?
Yeah, definitely. I've also got a big monitor, so I know everything is pretty small. Yeah?
Thank you.
Okay, perfect. So some of the things we're going to cover. So first we're going to install and import our dependencies, of course, first step in any tutorial. Then we're going to go and download that custom data that Jacob just showed us how we can annotate and generate. Then we're going to visualize some of our training samples and make sure that they loaded properly. We're going to look at writing our training configuration, run training and inference, and then we're going to visualize how it performs on some new and unseen images. So one of the many great things about Paperspace Gradient is that so we're going to have a link also to this notebook at the end. You can fork it and run it for free in your own account. We have free GPUs and CPUs. You can run it on a free instance. And when you fork that instance, all of these libraries are going to come installed. So you actually don't have to run this step. And I'm not going to run it now because everything's installed as well. But if you're running it on a new instance or if you're running it locally, I mean, we have things here like the specific PyTorch version, Torch Vision, and so on. We're also going to install Detectron2. And then we're going to go on to our imports. So we're going to import some common Detectron2 utilities and some basic libraries like NumPy, OpenCV, Matplotlib, and so on. So now for the data. So Roboflow makes it super easy for us. We're just going to take that link. This is my link that I just pasted here. But essentially you would just, sorry, I have my German keyboard on. You would just paste your link here, and then this command is going to download that, unzip that, and put these in the test, train, and valid folders right here. So then all we have to do, as with any custom data set, is just tell Detectron2 how to obtain that data, and we're going to use the register Cocoa instances method to do that. And we're just telling them now where the data is located and where the annotations are located as well. So just to make sure everything has loaded properly, we're going to use our visualizer to draw the bounding boxes over some of our training images. And you can see some examples here. So this is and you can see that images, so I'm using the augmented data, so they're going to look a little bit different. But yeah, so images are going to have 3 classes. So here we have a white blood cell. Here we have different examples of red blood cells and a white blood cell as well. And there are some platelets floating around. Oh, that's great. We've got all the classes in these images. Perfect. So the job then is to take our pre-trained model. Oh, sorry, I've got it open also in our IDE here. So I'm just getting confused about which one to run. But yeah, so let's move on then to training. So we're going to also import our own trainer module here to make sure that we're getting all of our MAP and recall precision, everything printed as well. Then we're going to use the config module. So Detectron2 provides a key value-based config system to get kind of basic behaviors like this. So we're going to first define our training and test sets. We're also using a pre-trained model from Detectron2's model zoo. So we're using faster RCNN, a very common object detection model. It's got a ResNet backbone with feature prediction networks. And we're also going to set some of our hyperparameters, our learning rate, how many warm-up iterations before that kicks in, how many images per batch, and so on. So we're starting off with these weights already obtained when the model was trained on Cocoa. If you're not familiar with Cocoa, it's a really common object detection data set, common objects in context. So our model so far has seen objects like cars and planes and animals or fruit, just typical objects, but it hasn't seen blood cells before. So we're going to do fine tuning to make sure that it can learn from our new data. So when training is run, I'm not going to run training here. It takes about a half hour on a P4000 GPU, but it's already been run, so we can see some of the logs as well. So first we've got the architecture here printed. It's pretty big, 101 layers. I'm just going to scroll past this. And then we're going to see some stats. So we're going to see, for instance, how the data set is broken up. So these are the number of instances of, for instance, platelets and images, red blood cells and white blood cells. And then we're also going to see how our loss progresses over time. And eventually we're also going to see this is printed over different epochs, so we're going to see it printed a few times. And we're also going to see our average precision and recall as well. Lots of very verbose output. So now going on to testing. We're going to test on new data. We're going to see similar logs. And that's, just to see performance on test. And now we can see that in our output folder, we have our newly trained fine-tuned model and model final. And we're going to take those new weights and we're going to see how it performs on new images. So we can see it looks like it's doing really well. This is a little bit tricky. So you can see this is probably a bunch of red blood cells, but since they're in this blob kind of configuration, I think it's pretty reasonable that it didn't know how to detect that. I should also add that we added here this threshold of 0.7. That means it has to be 70% or more confident to determine that a bounding box should be drawn over an instance in the image. So we can see here, we shouldn't see anything below 70% here. For instance, we can see here, we have a red blood cell labeled with 76% confidence, white blood cell with very high confidence, and some platelets as well. We have, and we have some other examples if we scroll down as well. But overall, we can see that definitely worked. Our training has definitely worked. Our model can correctly identify new instances of these objects in our training data, or our testing data. And that's really all there is to running an end-to-end Detectron2 object detection model on your own custom data. If you wanted to run this on your own data or use the open source dataset hosted by Roboflow, you just hop over to Roboflow or label new images. And then if you fork this notebook, you can run it on a free GPU and do this end-to-end on your own projects. So with that being said, I'm gonna toss it back to Matt for questions and answers.
Awesome. Thank you very much, Rachel and Jacob, for walking through that with us. I'm excited to be able to share some questions with you. So as I mentioned earlier, everyone, if you have questions, please put them in the Q&A box. You should be able to see that button at the bottom of your screen or at the top of your screen, depending on if you're maximized or not. So I'm just going to go ahead and open up the Q&A and start reading some of the questions here. So someone asked, are TPUs on the roadmap? And my best guess is that this is a question for Rachel. Can you talk a little bit about whether or not TPUs are on the roadmap?
Yeah, so it's definitely something that we've heard from some users before. It's not something that we've heard requested frequently. I'm not completely sure what the roadmap is for TPU use is right now. We definitely have many different GPUs that you can choose from. But yeah, that's definitely something I would stay tuned for.
Awesome. And then next question is, this will be for Jacob. So David asks, is there an upload size limit if you're working with really large data sets? And I want to try and break that down a little bit in terms of the number of images that someone may upload, as well as the size of the images themselves. Can you shed any light on that, Jacob?
Yeah, that's a great question. I mean, definitely, as we all know, more data is always better. So the larger and more diverse data set that you can collect is always better. For example, here we saw the example of the cells where they were all kind of squished together and the test detections weren't working so well. So maybe more similar images in our training set would help us with cases like that. But the answer is there is no limit really to the amount of images that you can upload to Roboflow. I have definitely broken it in loading up like the Cocoa data set, which is like 200,000 images or so. But you can always get past those limitations by uploading in sections. And then as far as the image size limit goes, we do have it prepared to handle very large images. So of course, just throw them at us, and we're always happy to help if you hit any limitations there. But then the important thing to know is oftentimes your images will then be resized down in pre-processing when you move on to training so you can actually like there's a certain level of image size that will probably be intractable for GPU memory to be able to handle, like maybe like 5,000 by 5,000 pixels or something wouldn't work. But I'd say try it out and give it your best shot, and we're happy to help.
Cool. Moving on to the next question. So as a heads up for everyone, if you can make sure that you share the question in the Q&A box. I'm also keeping an eye on chat, but there should be at the bottom of your screen, there's a chat button and there's a Q&A button. And the Q&A button is where I'm going through those first, and then I'll get to chat. So Amir asks, which data format should I be selecting for Detectron2? And related, another question from Amir about that. Is there a specific format that we need to follow while doing annotation, and is JSON or XML or CSV or any formats better or worse than others? So I'll kind of toss this to the group at large here.
Yeah, so just jumping in on, I'm pretty sure it's Cocoa JSON is what Detectron2 takes. Is that right, Rachel? Yeah, so Cocoa JSON is the one you want to export for if you want to use Detectron2. And then, yeah, what annotation to work with as you're annotating. So that is kind of the exact annotation format is kind of an after the fact question. So most of the annotation tools you'll be working with, whether it's Roboflow or other annotation tools like CVAT or VOT or wherever you're doing annotation, they'll represent the boxes in their own format, and then you choose an export format to export into a certain annotation format. But if you're working on annotating your data yourself, and you want a format to like annotate in, I would definitely avoid that, and I would use a tool, because that could take many hours to days.
Cool. Yeah, one thing to note, I did just put a link. So Roboflow has a link to a lot of different model notebooks that you're welcome to take a look at. One of them is for Detectron2, and I believe that is the source notebook for a lot of what Rachel showed earlier today. Is that right, Rachel?
So, well, we'll be sharing the link to the Gradient notebook as well, and that one can then be just forked into different accounts on Gradient. I'm not sure. I'm not familiar with this one, but yeah.
Okay, awesome. We will. So there was another question about that, about making sure or asking if the notebook would be available. The answer to that is yes. So you will all be able to see that notebook as well. I also shared in the channel, you can learn more about the Detectron2 notebook or the Detectron2 model, as well as the formats that are expected or required for that. You'll be able to see that by heading to that link. And at that link, you'll also be able to see a lot of other models that exist in the object detection and image classification realm. So looking at other questions that come up, someone asked, can we upload data series? So for example, if I would like to distinguish between satellite images of meadows and cropland, on some pictures they would be just harvested and very much look similar, while other images might be grassy with green and crops, pictures that have grass would be green and crops would be yellow. So I might want to upload a time series of crops and one time series of meadows in different seasons. Jacob, can you talk a little bit about the ability to handle sequential data or perhaps video data even in Roboflow?
Yeah, so as far as sequential data, the data will be processed in order of upload. And for video, I believe we now have it implemented, so that will be processed in sequence as well. I definitely see, though, the idea of maybe splitting data sets out into two different kinds of, like, for different seasons, for example. And there might be more to the data question there and data organization, but certainly those questions are left up to the domain and the challenges of the unique domain that you're tackling.
Cool. Next question, Jacob, this is for you. If you have several different data sets with different labels, does Roboflow have a way to merge them? And then would you be able to use that perhaps to train a Detectron model or other models?
Yes, you can merge data sets in Roboflow, so that's exciting. In the early days, we would just have to download the zip onto our computer and then re-upload it into a unified data set. But now you can do that with just a click of a button to merge. So yeah, merge away.
So there's more questions, and given that I'm going sequentially, I think a lot of these are for Jacob as opposed to Rachel, but let's skip ahead and do one for Rachel. Someone asks, it looks like Geetha asks, why are we using Paperspace instead of Google Colab?
So good question, and the answer is so many reasons. So first of all, Gradient comes with a lot of bonus features that Colab doesn't. The storage is going to be faster. It makes it really easy for you to work alongside with your team. It also makes it really easy to go beyond just working in a Jupyter notebook and do more things like experiments and running jobs and actually deploying your model really easily, even in one click. Other things, so a huge complaint from people who are using Colab is that your instance can actually be preempted at any time. Even on our free GPUs, we guarantee the entire session, so you don't have to worry about, like, I don't know, if you shut your computer, is everything going to have to, start again? Or, oh, I trained my model for 3 hours, but then I got disconnected. Now everything I did was lost. So I would say those are a few of the clearest benefits. There's definitely more. You could definitely, we recently wrote a blog about it or an article about it on our blog. And you can also email me and I'll talk your ear off about, about reasons why you'll want to do that.
Yeah. I just want to jump in there with one other consideration for me is the ability to specify the container that your notebook is launching from. And then you know that your notebook is actually going to be solid and not shifting. So Matt did share a link there to the models where we have some of these models implemented in Colab. But that's kind of a proceed at your own risk because Colab often shifts their environment underneath you, and then you'll get all these errors, and then they'll think Roboflow sucks or whatever, our model library sucks. But that's another huge benefit, I think, of the Paperspace notebooks.
All right. I am bouncing back and forth between the chat, the Q&A, and trying to answer a couple of questions. Jacob, let's go to you. So does augmentation increase the data set size in Roboflow? And can you talk a little bit about augmentation and what that means within Roboflow?
Yep, yeah, certainly. So to kind of do a review, there was the 2 different steps. There was pre-processing, which we applied to training, validation, and test. And that doesn't increase the size of your data set. It just sort of standardizes and reformats images. Augmentation, on the other hand, is applied to the training set only, and it increases the number of images that you're going to be using in training to show the model. So you can specify how many forms of augmentations you want to use, and you'll see in the augmentation options, you're able to like choose different settings for augmentations, and then we kind of select some random value in that neighborhood to make a random augmentation, and you can augment up your data set as large as you want. I think we typically don't go much higher than 50 augmentations per image, but there's no reason why you can't try more than that.
And then related to that, Jacob, can you talk about, so the question here, does Roboflow provide a heuristic that will tell you the number and type of augmentations you should generate based on an expected map score or mean average precision and the model that you will use?
Yeah, it's certainly something we thought about, which is, like, how can we automatically suggest the augmentations to take? The answer in the current time, the current state of things is there are certain AutoML solutions where you'll just put in your data set, they'll automatically choose the augmentations for you. You won't see any of this stuff. It'll just kind of happen behind the scenes, auto-aug, if you will. But we think that for the most part, so many of these domains are so unique that choosing the augmentations on your own and thinking about your problem from your point of view is very important. And so that's why right now there are no auto suggestions, and you should think about, like I was talking about, the real world deployment of your model and the way you want your data set to change, and choose the augmentations yourself. Matt, I don't know, did I get the whole question there?
You did. In addition to that, so one of the things that does exist in Roboflow to answer this question in terms of what augmentations you should pick, whenever you open up a pre-processing or an augmentation option, there is the opportunity when you, for example, if you looked at random rotate or random noise, when you're deciding how much rotate to put in there, there's a link at the bottom that will take you to a blog post that in that blog post, you'll be able to read more about, in many cases, the background behind that augmentation and when you might want to use it, when it might not be a good idea to use that, and what problem it solves. One example that comes to mind, you might explore, should I tile my images? And it will link to a blog post about about the small object detection problem, because tiling is one technique that may be particularly good when detecting small objects, and that gives you, the user, guidance around, should I be using this or should I not in this particular situation? But as I think Jacob started his answer with, it's ultimately going to be up to you as the subject matter expert of your data, and you'll know, hopefully with a little bit of our assistance, you're going to be able to be a better judge of what augmentations are needed for you. The next question that let's see. So there are a couple of questions around deploying models. So people are asking, let's see, Felipe says, after the Detectron model is ready, how do we produce it for deployment within Paperspace?
Really good question. I'm not going to go into a whole demo now. You can definitely find detailed information in our docs, and I'll put a link to that also in the chat. But basically, it's super easy. There are a few different ways you can do it. First, you could save your new pre-trained or your new fine-tuned model. Just upload it to the model repository. If you're doing it from the Jupyter Notebook, you would then download it and then upload it to the model repository. And then there's just a one-click deployment option. You can also do it from our deployments tab, where you would upload the model there, and then it will just in one click deploy it as an API endpoint that you can use. But yeah, I would be more than happy to give more demos about that later.
And then related to that, Jacob, even though it's not a specific query that came in here, do you want to talk a little bit about deployment with via Roboflow and sort of what's on our roadmap, and what are we currently supporting?
Sure. Yeah. So the Paperspace deployment is super awesome for you can deploy onto a GPU, and Rachel, I think it auto scales and everything. So this inference is like you can completely offload it to the cloud. One thing we're working on at Roboflow is making deployment options for like edge devices. So if you want to take these computer vision models and put them on like an NVIDIA Jetson, or onto your web browser, or onto like an Oak device. We got one of those right here. Looks like this guy. So you can kind of like give your device eyesight and such. So that's another area to think about when you're getting to deployment is, do you need to put it on the cloud? Do you need to put it on a device? But yeah, like Rachel said, I'd say largely out of the scope, or we're not doing a full demo on that today. But once you have the model working, then the real work begins.
So I can jump in here with an answer to a question. So Sasadara asks, what if we have different versions of annotations, and can we use those data directly with Roboflow's annotator and use with another architecture by transforming that data into the Detectron2 variant? So remember that in order to build a Detectron2 model, you need your images and your annotations to be in CocoJSON format, or specifically the annotations themselves need to be in CocoJSON format. So the question here is, can I upload images that have a different annotation format and then convert them in Roboflow? And the answer to that very broadly is yes. There is and I'm pulling up the link here. There is a link to all of the formats that we support in Roboflow. So one of the original common use cases of Roboflow was to be able to say, how do I convert CocoJSON annotations to TensorFlow TF records? Or how do I convert Pascal Voc XML to CocoJSON? Or how do I convert A to B? And so Roboflow has been built to address a lot of those challenges. So the short answer is yes, Sasadara. If you've got a different annotation format, if it's one of the common annotation formats, I believe we support like 20 or 30 different formats. I would have to double check the link that I just shared, but check that. And if there's a specific format that we don't have, feel free to reach out and let us know. We want to make sure it's as accessible as possible. Looking at some of the other questions here, there's a few questions around image segmentation. So we've had questions around, does Roboflow support segmentation? Does Roboflow support polygon masks or polygon boxes as opposed to specific like rectangular bounding boxes? Jacob, can you talk a little bit about that?
Yeah, so on the segmentation topic, it's somewhere we want to eventually get to, but it's not currently supported. I mean, the reasons behind that is you can imagine is like with a polygon mask, it's a lot more complicated than a box, and all the augmentations and pre-processing steps gets quite a bit more complicated. So no, we don't support segmentation at this time. I do believe Detectron2 does, though. I could be wrong there, but I think there are some models in their model library that you can use for segmentation, and of course you can be training those with Paperspace, but using Roboflow for those, the annotation manipulation of masks is not possible currently.
All right. So we're nearing the end. We've got about 10 minutes left. So make sure that you continue getting your questions into us. We'll try and get through as many as we can in the last 10 minutes that we have. There are a few questions that people are asking. So Justin is asking a question. Shanker is asking a question around how do you pick which model to build? And is there the ability to maybe tune over multiple models or determine how many layers you should have and all of that? So Rachel and Jacob, feel free to chime in on how do you make the decision when it comes to fitting the Detectron model or something else? What do you consider? How do you make that call?
So I don't know. I'll say my input, Jacob, if you want to add something, definitely feel free. So this model we chose because it's actually listed in the Detectron2 GitHub repository as the best trade-off between speed and accuracy. But that's definitely a good question, right? That's a huge hot topic in ML in general and DL in general, is how to choose the right model, especially for fine tuning. A very obvious thing would be what data has it already been trained on. So we chose something that's been trained on Coco, not, for instance, ImageNet, because we are fine tuning it on another bounding box object detection task. When it comes to layers and everything like that, I hate to say it, but in my experience, you just have to try different things and see what gives you the best results. I don't know, Jacob, what do you think?
Yeah, totally. This is a great question for us. We could nerd out on this all day. But yeah, I would certainly say, at least in my opinion, as you're getting started out, I think it's almost always mostly a data set problem at first. And then to iterate on your data set and to see what problem you're working on is solvable, I always go for training time. Try to find the thing that you can train the fastest. So having a nice GPU is always nice for that. And then choosing a PyTorch model. I'm going to throw in my hat for PyTorch here.
All right, perhaps some rapid fire like yes, no answers. For Jacob, can you upload data straight from object storage, S3, Azure Blob Store? Is that something that Roboflow supports?
Matt, you might know better than me on this one. I think the answer is yes. We have an upload API where you can like automatically post images from a URL, and I think you can connect into those storage buckets, but I'm not sure.
I publicly answered that question with the documentation that we have for the upload API. So feel free to take a look at that, and that should be able to better answer your question. Rachel, for you, what are the specs of the free virtual machines?
So when you say virtual machine, I actually think of our core product. You might mean, because we also have full VMs, and I can link to those specs as well. But if you mean like the CPU and GPU instances, I'll link to that in the docs as well, because I don't have it all off the top of my head.
Yeah, that's definitely an in the weeds, a lot of technical details. In addition to that, sticking with you, Rachel, we've got in Gradient, when working with large data sets with large image sizes, there seems to be a problem of RAM reaching its capacity. Do you have recommended ways to perhaps troubleshoot that or tackle that don't involve reducing your number of images or resizing your images to be smaller?
Yeah, so it's hard to say without knowing the exact error you're getting. In my experience, you can usually decrease the batch size, and that will reduce any memory errors or just clear your cache. It really depends on, for instance, what PyTorch is caching. I've seen that error happen. But yeah, without knowing the exact error, it's hard to say.
Jacob, for you, is alpha blending on the roadmap, i.e. swapping out backgrounds while keeping the object in the bounding box for Roboflow?
Yeah, we've definitely thought about that quite a bit, like this idea of like synthetic data. If you have a resource or a article that you want to share on that, I'd be really interested to take a look. And I'm gonna also post a blog where we have an example of how you can use not within Roboflow, but you can use a script that we wrote to generate something similar.
Cool. Let's see. Shrey asks, can I access a Paperspace machine using SSH?
Yes.
All right. Easy yes, no answer. That's great. Let's see. So Henry asks us, how does Roboflow's augmentation interact with Detectron2's built-in augmentation options? Jacob, this is for you.
Yes, built-in augmentations. Those are an option in most training, in most models you'll be training. And I don't know if in the notebook that Rachel and I provided today, if there's a section in there for that. But I would always recommend to just turn those off and then use the Roboflow augs. So then you can visualize and kind of pick them carefully. But you can always mix and just know that you're sometimes auging on top of other augs. But I don't know. Generally, I've seen that continuing to aug is okay. Just good to be aware of it happening in the background.
Yeah, there looks like there's a decent number of questions around, and I'll jump in and answer this. So someone asked, is YOLO, or which one is faster to converge, YOLO or Detectron2? And broadly speaking, I think a lot of the decisions here are, it's going to depend on what exactly you're working with, how many images you have, how many, what's the size of the models themselves. So YOLO and Detectron are obviously two different models here. But I think that there's a lot more nuance than one is just uniformly going to be faster to converge than another. Rachel and Jacob, I'll let you jump in if you have specific thoughts around the YOLO family versus Detectron2 here in terms of training time.
I'm a big YOLO guy. I really like the YOLO models. But the thing about the YOLO models is you don't have like a full library like you do in Detectron2, where you can just swap out new models out of the model library. Once you're in YOLO, you're there. And then the other thing is most of the YOLO models are implemented in darknet, and even with Rachel's powers, you're not going to have a base container for darknet. So that's always fun. But yeah, YOLO v5 PyTorch is a nice model. We like that one.
Rachel, are you going to step up and are you going to defend Detectron and be like, Detectron is better than YOLO?
Well, I'm biased because I actually haven't done much work with the YOLO models, but I have worked with Detectron. So I would just reiterate Jacob's points on, you got this full library and a ton of documentation and the whole Detectron API and working with custom data. So I don't know, if you're jumping in, Detectron is friendly. That's my defense to Detectron.
Was hoping that we had two people with very, very staunch opposing options here, and we could fight about training time and inference time and size of the model and performance and all of the things that make these just such hard questions to answer, but make for a more dramatic and more fun end to our webinar. The last question that I have, and this is actually for Kaylee, who's going to make an appearance on our call very quickly. An attendee asks, will there be future webinars focused on Roboflow and deployment, specifically looking at edge deployment?
Well, hello. I'm Kaylee from Roboflow. You guys have seen me floating around in the live chat, but I've not had my video on so far. Yes, we will be doing weekly webinars starting in April for anyone who wants to join. They're open to the public. The first Wednesday of every month will be kind of a special webinar where we bring in a guest to share something about their focus in the field of computer vision. The remaining webinars will be very specifically focused on deployment, training a model, augmentation, all the great aspects of computer vision that we think will provide value to you and help you on your own journeys and with your own projects. Thanks, Matt.
Thanks, Kaylee. Yeah, and someone just put in the chat, how can we sign up for the webinar email list? That's a great opportunity for me to share that, again, this was being recorded. You're going to get a version of this recording afterward. You will all be contacted via email. So with that, you'll be able to get access to future webinars. But given that we are almost at the top of the hour, we've got about 20 seconds left. Thank you everyone so much for joining us. Huge thank you to Rachel Rapp from Paperspace and Jacob Solawetz from Roboflow for your time and your great demo today. Like I said earlier, this is being recorded. It's going to be shared in a follow-up email to you. Be sure to check out Roboflow at roboflow.com, and be sure to also check out Paperspace at, you guessed it, paperspace.com. Huge thank you to our partner Paperspace for helping to put this on. Stay safe, everybody. Thank you all very much. And we look forward to seeing you at future webinars and events. So thank you, everyone. Take care.